Welcome all to Basic TDL Tutorial Session 1. In Session 1, we would be discussing about TDL Introduction, TDL Components, and Symbol and Prefixes. To begin with, we would be starting with the TDL Introduction, that is the Tally Definition Language Introduction. Tally Solutions has been in the business of providing complete business solutions for over 20 years to micro, small and medium enterprises, and to a large extent for large enterprises also. With over 3 million users in over 100 countries, Tally, the flagship product, continues to be the preferred IT solution for majority of the business every year. Tally, which has been started as a simple bookkeeping system 20 years ago, is today a very comprehensive integrated solution covering several business aspects of an enterprise. This includes accounting, finance management, receivables, payables, inventory accounting, inventory management, BOM-based manufacturing inventory, multi-location, multi-currency, POS, group company consolidations, statutory compliances like excise, VAT, CST, TDS, TCS, FBT, payroll accounting, and many other major and minor capabilities. With the introduction of the remote access, remote authentication, support center, control center, account management, and online help inherently supported in the product can be formally labeled as ERP9. Along with this introduction, we have also provided a tax audit tool for the auditors. So, as a complete business solution, we have ensured that the order to payment processes are being completed, order to receive sales processes are there, manufacturing processes are made available, payroll is made available, maximum MIS reports, statutory compliance, and we have provided a TallyNet environment. Hence, Tally ERP9 is just more than an application. It is a complete development platform for the developers. TDL is the development language used by Tally ERP9 developers. Tally Developer 9 is an editor provided for the developers specifically to write TDL, which will aid the developers to write TDL for Tally ERP9 more effectively. The editor is aware of the language structure and has capability to identify the syntaxes and compilation errors, and hence it facilitates the developers for quick development and also helps them to deploy these extensions very rapidly. Tally ERP9 as a development platform has been designed as a business solution catering to functional requirements. The development platform allows the application developers to change the default functionalities. The current existing look of the voucher can be changed. The invoice printing can be changed. The way the current report is being displayed can be changed. The way the end users and the application developers view Tally ERP9 will be completely different. Well, the Tally product is same whether it's for the developer or whether it is for the end customer. However, the vision or the prospect to look at the product will change completely. The end user interactions take place at the product interface through which he exploits complete functionalities offered to them like the MIS report, order payment processes, order to receipt, that is the sales process, material to material manufacturing process, payrolls, MIS reports, statutory compliances like the TDS, TCS, FBT, excise, sales tax, VAT, CST, and also the enabling environment for remote, that is through TallyNet. However, from the developer perspective, the Tally definition language provides a development platform for the TDL developer. TDL provides flexibility and power to extend the default capabilities of Tally and integrate with external applications. The language developments at the platform provides capability of rapid development, data management, and integration for TDL programmers. TDL is an action-driven language based on definitions. Hence, as a TDL developer, there is a layer of TDL about the artifacts of interface objects and data objects. So, as an application developer, the layer about TDL layer is what the end customers view. As a TDL developer, developers will work with the artifacts of interface objects and data objects. This is understood by the platform layer via an TDL interpreter. TDL has been developed as a simple English standard language, whereas it has to connect to the machine language. Hence, to understand the simple English for the machine language, the application developers or the platform developers have created a TDL interpreter. This interpreter converts these artifacts simple English language into the machine language for the hardware layer to understand the platform. At the platform, we have the DB engine, that is the database engine, ODBC engine driver, parsers, business logic and user interface engine, a functional library, an output engine, and the memory management. This platform is being handled with the help of OS calls, data structures, and algorithms, where there is a hardware layer and there is a hardware OS. This is how this entire TDL works. Hence, Tally definition language is a comprehensive 4th-generation language and provides more capabilities than any other 4th-generation language, as provides capabilities for rapid development, rendering database rendering, data management and integration, report designing, screen designing, report generation, and many such functionalities. Capabilities are for rapid development, multiple outputs, data management, and integrations. So the TDL definition language is the application development language of Tally. It is a 4th-generation high-level language. TDL is an action-driven language based on definitions. It emphasizes strongly on the concept of reusability. It compromises of interface and data objects. Interface objects merely determine the behavior of the product in the terms of user experience, whereas data objects are mainly used for the data persistence in the Tally database. Any user of Tally ERP 9 can learn TDL and develop extensions for the product, as the entire source code of the product is made available as a part of Tally development environment with our product Tally Developer 9. TDL is deployed only by use and not mere existence. This makes us understand that only by writing TDL and placing it into the Tally folder would not make the TDL active. You need to connect this TDL file with your particular Tally ERP9 application. And very important thing is Tally definition language. TDL is a non-procedural language which makes a common man write this write a program in TDL very easy. And this is a glimpse of a TDL program, a basic TDL program, which you can just have a look. It has a pink you see on the within the square brackets is the definition. It makes the program understand it's a definition. The one in the pink color is the definition type. The one on the right of the definition type is the name of the definition. Each definition has its own set of attributes. Then the gray one are the attribute modifiers. Every attribute has its value. There are something called as formulae. There are special symbols. There are action keywords. Well, this is a very basic code, and the output of this code would be my first TDL text in your screen. And going further, we will understand on how do we write a TDL. Now we move to the next chapter, TDL components. As we have just discussed in the previous lesson, the previous presentation, TDL is a language based on definitions. It is an action-driven language. So whenever a user performs an action, but a particular segment of code gets executed, and it is non-procedural by intent and concept. TDL enables the extension of Tally to incorporate additional functionalities or modify the existing functionalities. We have already seen that TDL language is based on definitions, and we have two artifacts, the interface artifacts and the data we have the interface object artifacts and the data object artifacts. And we have discussed that it is a definition based language. Hence, on this interface screen, as you can see, there are four visible interfaces, that namely are the menu, button, report and table. In TDL, specific definitions are provided to create the same. A report and a menu can exist independently. A menu is created by adding items to it, while report is created using form, path, line and field. These are the definitions which cannot exist without a report. TDL operates to the concept of an action which is performed on the definition, and the definition on which the action is performed. The report is invoked based on the action. Let us show you the Tally screen itself. And this is the Tally screen. This is the menu. From the end of this green panel till this end is the report. On the top that you see and the right and the bottoms that you see here are the buttons. And this drop down box or the pop-up list is known as table. Let me just repeat. This is menu. The one that you see from this top panel, the green panel till this edge is the report. The top panel, the right panel and the left and the bottom panel that we have are the buttons. And this drop down box or this pop-up list that we call is the table. The TDL program to create a report contains the definition, report, form, part, line and field, and an action to execute the report. So the basic hierarchy of any report designing is report, which contains a form that contains part that contains lines that contain field, and field is where the contents are displayed or entered. So let us have a quick recap again. A report has a form has parts, a part has lines, line has fields, and field is where we display our data or we enter our data. Now let's have a quick recap again with a little change. A report has a form. One form in a display mode can have multiple forms in edit mode, in print mode or an export mode. A form contains vertical parts. A form contains vertical parts. A part can contain further parts or lines. However, at the end, each part should contain lines. Parts contained in parts can be horizontal. Lines are always vertically sequenced. Line can further contain line or fields, and at the end each line will have fields. Fields are horizontally placed in the line. A field can further contain fields. At the end, finally, a field will display the data. Let me repeat this once again. A report has a form in a display mode and can have multiple forms in print and export mode. Form further contains vertical parts. Part can further contain parts or lines. Please note, here we are stating part can further contain part or lines. These contained parts can be horizontal. Lines are always vertical. If a part contains part, can further contain parts, however at the end the last part in the hierarchy should contain a line. Line can further contain line or fields. Again, the lines will be vertically placed and fields will be horizontally placed. Line can further contain lines, can further contain lines, can further contain lines. The last line in the hierarchy should contain a field. Field can further contain more fields. At the end, the last field in the hierarchy can display the data or allow you to enter the required data. Repeating the hierarchy once again. Report has a form in a display mode and can contain multiple forms for the print or the export mode. Form contains vertical parts. Parts can further contain horizontal parts or lines which are horizontal. Lines can further contain lines or fields. Fields can further contain fields or can display the data, or you may enter the data. So the basic hierarchy of a definition of the definitions for the report is: report contains form, form contains parts, part contains lines, line contains fields, and field is where we display the data. And this is our basic Hello TDL program. This demonstrates a basic structure of TDL, and this can be executed from the menu gateway of Tally. So let us just start writing our first basic report, Hello TDL. So opening the product Tally Developer 9. This is our product Tally Developer 9. This is the project pane. This is the project properties pane. This would be the editor pane. And this would be the output pane. So we will first create a new text file. So file, new file, Hello TDL program. While writing this basic Hello TDL program, we would be explaining you certain required shortcut keys and frequently used modifiers. So please do take utmost care of this. Open square bracket, hash, menu. Now there is a shortcut key to know the list of definition types available. That is control space bar menu. And which menu? Gateway of Tally. And close definition. So this is the definition type which we would like to modify. How did we know which definition to modify? Well, now this is where we will start working on our Tally for understanding. So right now we do not have a data, so we'll just create a company. We will make ABC Private Limited. Control A. Now here is where we want to add our menu item Hello TDL. The only way to identify the menu name, the only thing that we know is the text that we have here, Gateway of Tally. So now we go to Tally Developer. Control plus D, D for Denmark. Open quotes because it is a title, so it's a string character, and the text that is there is Gateway of Tally. We will search in default TDL project. We have multiple options here, and since it is a string, we will give search in strings, and we will give a tally search. Now what's a tally search is, tally, when you type in tally, it ignores all the noise characters and it is case insensitive and space insensitive. So even if there is a small case or a space difference, tally search will ignore that and still will search for the strings which are of similar kind. And we click on find. As you can see, we have two search outputs. Now the file structure has been made so simple that even at looking at the file path and name, you will understand whether you are at the right place or not. For example, DEF TDL stands for default TDL. SRC stands for screen /help/help.tdl. Are we looking out for help.tdl? No. DEF TDL, that's default TDL. Screen, yes, it is my screen. Menus.500. So are we looking for menu? Absolutely yes, and we press enter. So it has found the title, and this is the title. And to ensure that we do not make any spelling errors, we can copy the text from here, select Ctrl+C copy, go back to our file, and we can paste here. However, to modify an existing definition, the symbol that the definition type has to be prefixed is hash. Hash is a special symbol to modify the definition type. So hash indicates the programming language that the definition type Gateway of Tally already exists in the menu. Now, what is this for the menu? It's a title. So this, we have a attribute called, again it's a control space bar, TITLE, title, and we change this title to ensure that we are at the right place, and we type simple accounting. This is the coding standard that we follow. The definition type from the leftmost and the attributes with one tag. So as you can see, open square bracket, hash, menu definition type, separated by a colon, the name of the menu Gateway of Tally, close square bracket, and you will notice the moment you give a hash here and your cursor comes, it turns into a hyperlink. So when you control and left click, it takes you to the original definition of the definition type, title, and the title we have provided. This is one simple test that we are going to run on the existing program, and we will now execute this. There are, as a customer, there are two ways to attach a TDL to your Tally. One, you can go to your Tally folder, in here we have tally.ini. Here we have used this parameter user TDL is equal to yes, and you can provide TDL is equal to, and you can provide the entire path of your TDL. This is one way the user can do. Open Tally INI that exists in the Tally application folder. User TDL is equal to yes, and TDL is equal to the file path with the file name and the extension. This is one way the user can do. Another way the user can open Tally application. F12 TDL, that is product and features. F4 manage local TDLs. Here you can copy and control all to be paste the file path and save this. Here you will be able to see we have a file name here that we have given. D drive, and the file path is entered, and this is the local file. Another way that you, now this is what a user can do. So F12 product and features, F4 and manage local TDLs. Now you are not a user. Obviously this is for a particular customer, and as a developer makes no sense for you to give the file path in your application. What as a developer you can do is tools, preferences, compiler and execution, provide your Tally exe path, the working dictionary path, and the options that you want to provide, and you say OK. From here, right click on the file and say execute Tally. Tally is executed, and here you can see the TDL has been added, so you can see TDL here. F12 product and features, and here you will see the file. Now when I press F4, it is not available here because it's just a temporary execution of this text file from your Tally developer. It does not exist in your configuration file. Right? Now we'll just select our company, and we'll do one thing. We will load it by default. So F12 data configuration, and by default load a specific company. Yes, and we'll ensure that the company is loaded. data configuration, C programming files, and so select, I have my data. Yeah. So do you see the text here? It is changed to simple accounting. So this is how you test whether you are at the right place for this particular menu. Now we will add a new item to our gateway of Tally. So what do we want to do? We want to add. What do you want to add? Now we will add a key item. The name of the item will be first TDL. So that's what you will see here. The first, here is where you will see the first TDL. What is the key? So you can select the key. What do you want to do? Display. What do you want to display? My first TDL report. So this is how it shows. Hash my menu definition gateway of Tally. Add what? Key item. Which item? First TDL. Which key? F. What do you want to do? Display. Display what? The report's name. Right? And now since we have declared that we would be using this report, we need to define this report. So open square bracket, report, my first TDL. Now what does a report contain? Report contains form, and I will write my first TDL form. Again, this is a declaration. So now we will open and say define the form. First TDL form. Now what does a form contain? Form contains part. First TDL part. What does a part contain? Part. First TDL part. What does a part contain? Line. First TDL line. This is again declaration. Now this is a coding standard that as Tally we follow. Line definition is one tab. So line colon first TDL line, and a line contains field. First TDL field. Field again is double tabbed. First TDL field. And field is where we display the data, and the attribute to display the data is set as welcome to the world of TDL. So that's the simple text that we have written. Okay, so we'll just revise this written code once again. Open square bracket as it's a definition, hash the definition type menu, colon gateway of Tally, close square bracket. We first made a change to the title and made it a simple accounting to ensure that we are at the right definition. What do you want to do? What modification do you want to do at the gateway of tally? We want to add. What do you want to add? Key item. What is the item name? First TDL. What is the key for this? F. What do you want to do? Display. What do you want to display? First report. Now this is a declaration that when I click enter on this, my report will get open. It's a declaration, so we need a definition of this report definition. So report, open square bracket, report definition type. Now here please note we are not putting a hash because it is a new report. This does not exist in default tally. Only if it exists in default tally you need to say hash. Report colon first TDL report close square bracket. Now what does a report contain? Form. The form name. Now again it's a declaration, so we will define this form colon first TDL form. What does the form contain? Part. And the part name, first TDL part. This is a declaration that this form will use this part or will call this part. So we define this part. A part contains line. So here we declare the line and the line name. So now this part will be calling this line. Now we need to define this line. Now a line contains field, so we declare the field name and we need to define the field, and field is where you display your data, right? Now the TDL is already attached with this application, so you can press F12, product and features, F4, and you can just re-accept the screen to refresh your TDL while your application is already executed. And now when you come to gateway of tally, you will see at the bottom, after the quit, first TDL has been added. F has been made red because that's my hotkey, the shortcut key, the key for the item. When we press enter here, welcome to the world of TDL. Clear? Definitely you will have some questions to this. Is it necessary to write report for the report definition? Absolutely not. But you have to ensure what you write here is what you define here. What you declare is what you have to define. So definitely the form, the writing of these definition type is not mandatory. But since we are the beginners for writing the TDL, we have specified the definition type along with the name. So we, as a beginner, we do not mess up writing or doing something wrong. So this is what it is shown, and this is the output of that code. Have you noticed on the top left panel, my report name is shown as my definition type name? So as we can give a title to a menu, we can also give a title to a form. We can give a title to a report, and we can give hello TDL, save the file, go back to tally application, escape, F12, product and features, F4, enter, accept, your TDL is refreshed, escape, first TDL, and on the left hand corner you see the title has changed. So if you don't provide the title, the name of the definition type is being taken as the title. If you provide the title, it will be taken as that particular title. Simple to write and simple to understand. It's the logical questions that we need to ask. Right? So we have been successfully written our first basic TDL. We have done this, right? Now we have seen how to create a file. We can specify it in TINI or for customers. You can either specify in tally.ini file or from the Tally application screen. Well, there is a new aspect also. You can do it through Control Center. Please refer to Tally Help Reference Manual to understand how do you attach a TDL to a customer's account and not from the INI, as when you are adding it to an INI, the file has to be physically placed into the customer's system. However, if it is through the account of that particular customer, then you can then it is abided with the customer's license, and any damage or physical loss to the system will not lose the INI file. In fact, wherever the customer activates his license, the TDL file will get activated. So please ensure that you go through the account TDL section that we have provided in Tally ERP9 folder, right? And right now what we have done is we have added the text file as it is. So this text file is readable even in Notepad. As you can see, the symbol that you see is the Notepad. So even if I don't have a Tally developer, this file can be opened and written in a Notepad. However, we do write in Tally developer, as you have already seen the benefit of writing in Tally developer. So we have opened the text editor, we have created a new file, we wrote the TDL code, we have saved the code, and we have attached it to the INI. This is what we have already shown. You can go to the Tally application folder. There is a file called tally.ini. Open the text file. User TDL is equal to yes, and TDL is equal to give the file path name with the extension, and the file is ready to use for the customer. Or you can go to Tally application, F12, the configuration button, go to product and features. On the right hand side you will see there is an F4 button, manage local TDLs. Then you will have option set, you have an option load TDLs on startup, set it to yes. And where it is asking for the file name, you can provide the file name. The moment you accept, it will be shown on your Tally screen and at the local area. If you are adding it through account TDL, it will be shown as account, which means physically the file is not present. It is abide with the customer's license. And we have seen the output in the Tally application, and there is a new option in Gateway of Tally menu. Now we will learn, before going ahead with more details of TDL, we will learn few functions and features of Tally Developer 9. We will not do it in too much detail, as we have already provided separate sections on various working of Tally Developer 9, and the dictionary manager and the developer mode of Tally. However, we'll just take a small recap of this, a quick working of this, so that you can do a quick working. For details, you can please refer to the recorded sessions of Tally Developer 9, Dictionary Manager and Tally Developer Mode. So we have seen certain interfaces. We have already seen this interface. Execution. Yes, to execute Tally, you need a valid Tally developer license. The license activities are similar to what we have for Tally. You have to activate. The first time activation, you require an unlock. You need reactivation. We have update, surrender. You can see the license info details. You can do a compilation, that is build, and you say compile file. It will start compiling and it will check for errors and warnings if you have in case. Right now the file names are shown at the bottom. You can go to tools, preferences, and this can be changed, like position of the file tabs on the top. You can say the keyword case, make it an uppercase. Please note all these visual effects will be only for Tally Developer 9. So in case you open it in Notepad, it will still be the regular case that you have typed. Make references underlined if you want. Tab size is 4, so you can change this. You can change the font type if you require. Explorer options. So there are various other tabs apart from the project pane. So whether you want to restore the last project and the file on startup, so when you start Tally Developer, the last project and the files that you have worked on will get open. Whether the project you want to view folder wise or not. So if you do not click on this, it will become file wise. We'll see what is a function browser and other things, and we have something called as action browsers, and we did see the compiler option. Okay, you see the file is gone on the top. This become references, is become underlined. There are changes here. We have a definition browser. So these are the list of default definition types available, and when you expand this, you will get the list of attributes that we have for each definition in default, and the explanation. So you will see at report we have something called as title. It displays the title for the report in the left corner. So that's what we have seen. Then we have the function browser. In this function browser, there are a list of functions that we have for our utilities. Right now, this is based on the category the function belongs to. So when you click on date, you will see all the functions that are related to date. When you click on amount, you will get all the functions that are related to amount. When you click on business, you will get all the functions that are related to business. Right? So, and then we have action browser. So at report level, these actions can be performed. At part level, these actions can be performed. At field level, these actions can be performed. It's a huge endless list. So these are specific actions that you can be performed. At menu, these actions can be performed. So we have a huge list of actions that you can perform at each definition also. These are the system level actions also available. So there's a huge list of actions that are made available in the action browser, along with which definition this browser can be used. Very important thing that you should know as a developer. Right now this file is in a text file and it's a modifiable file in the notepad. Definitely when you give it to your customer, you wouldn't be giving it as a notepad. Definitely not. You need to compile this file for a particular serial number. However, a text file cannot be encrypted, or we call it as build. It cannot be build or encrypted. So you need to have a new project file, and here the name of the project will say hello TDL, the location of the project, and we will add an existing text file to this project. So to encrypt a file, a project file has to be created and the required text file or files has to be added here. You can add multiple text files. Either you can click on new, add new files, and you can add one more file and save, or the other way is, say a file is created here, and you can remove the selected, add an existing main, save, and say you do want to add file to. One is you right click on the properties and you say add existing files or create new files, or with the help of a TDL command you can add another file here, and that is open square bracket include :2.txt, and the file gets added. Now comes the encryption or building of this for a particular serial number. On this, you first right click on the project, click on properties, so a project properties pane is open. In build options, you can give the name of your product, say TDL program. You can provide the author name. Suggested is you provide your company name, the name of the developer, and his or her mobile number. Then you can provide the versions, like as Tally is providing Tally ERP9 release 1.42, you can also provide your version numbers. So you can say release, or you can say version 1.0, release 1.0. You can provide. Compilation format, we have two formats. One is irreversible and one is regular. When it comes to irreversible, this kind or encrypted format of files cannot be decrypted even by the developer from whom it has been compiled, which means the developer will have to maintain the source code of every TDL file developed by him. However, it is applicable only for Tally ERP9 3.6 release and above that. Well, the developer has a choice to click on regular, which means a regular compilation. The developer himself can decrypt the file, and only he can decrypt this file, which means that irreversible does not even allow the owner of the source code to decrypt the file. When you click on regular, it will allow only the developer who has developed the file to decrypt it. If you want to provide a trial mode, you can give the trial duration of 10 days to your customer. You can say authorization required, denial loading in educational mode. Right now we do not have any customer, so we'll click on manage customers, add a new customer. The customer name is say Ratna. Serial number, we'll just take the serial number of the tally that we have here. It's 72000 3186. Customer email ID, if you want to add a group, you can add that, and you say add customer. Right now we do not have any group, hence this under a new other customers. You can group multiple serial numbers. Now for example, there's a customer A, he has purchased 5 tally licenses. You can create a group of his company and add each of its serial number to the group. Now you can click on save. If you click on group, all the serial numbers in the group will get checked for compilation, or if you want, you can select the individual serial number also. Now note this: the file name, the author details, the version details, enable for trial mode, authorization required, deny loading in educational mode, selected for the customer serial number, save and build. Now in the build tab you will see the details. Building the project, first it will do the compilation of the project. If any error will be provided, if no error, it will build the project. Project gets built successfully. The output file is available in the path with the extension .tcp. The minimum tally version that it can be used is Tally ERP9 Series A Release 1.0, which clearly makes you understand that you cannot develop a file for customers lower than this particular version. The TCP format is regular. In case the customer's tally is in education mode, the TCP will not get loaded. Yes, there's a trial mode, and from 10 days from today it will be 20th March 2015. So after this particular date, the TCP will stop working. Authorization required, yes, and it will work for only this particular serial number. So let us just quit Tally, go to Tally application, open it, and we will just attach the TCP file that we have here in slash and hello TCP. So we have this hello TCP home, copy in Tally, F12 product and features, F4 provide your file name, accept. Now you can see the name of your project has been mentioned here with its version and release, the one which you had mentioned here. Let me just show you the project properties once again. Right click, properties, the name of the product and the version, and when you go to this product, you press shift enter. It gives the author name. This is the author name, the developer name and its mobile number, and the format is TCP. Right? And when you come to gateway of Tally, the file has been added. Now we'll do one thing, we'll just remove the license to show you how it works here. So we will just change the license, multi-user, localhost 5009. Right? So we do not have a license here. So working in educational mode, you see here one TDL's license failed. When we see here, it is red marked, and it is a local TDL, but it is red marked, and you can click on add extensions if you need any extensions. Right now no extensions available. Everything you can press F12 and you can configure show author details, your product identities, additional details, everything. Expiry is on 30th of March, but if you can notice, it is not loaded. Right? So license is very important. Licensing, configure single user, and the moment we get the license, you know the TDL is loaded. So this is how it is loaded. Right? There's an overview of Dictionary Manager. As informed earlier, we have a separate recorded session for this Dictionary Manager tool. Please do refer to that recorded session for details on Dictionary Manager. Now coming to the important aspect of TDL. So this is what we could talk about the product. Definitely there is more to the product. So as and when you use the product, you will get more ideas on how to use the product. Now coming back to the TDL components. So the TDL component consists of definitions, attributes, modifiers, data types, operators, symbols and prefixes, and functions. Definitions. Tally Definition Language, or TDL, is non-procedural programming language based on definitions. This is what we had discussed earlier. TDL works on named definitions, which we have seen in one of our Hello TDL. The biggest advantage of working with TDL is its reusability of definitions. All the definitions are reusable by themselves and can be a part of other definitions. Whenever a change is there in the code, needs to be reflected in the program, Tally ERP9 can be restarted, or you can go and refresh the TDL. The syntax is very simple. Open square bracket, definition type, colon the definition name. So all the definitions start with an open square bracket and ends with a close square bracket. Definition type is the name of a predefined definition types list available in the platform. As we could see, we have the collection, menu, report, form, parts, line, field, button, table. All this is predefined. And how did we know all this? Very simple. Here we can do square bracket, control space bar, and this is a list of definition types that we have in our default, right? And the definition name is the developer defined, depending whether it is a new definition or it is a existing definition. This refers to any user-defined name which provides user to initiate the definition. So whenever a definition is created, a new object of a particular definition type comes into existence. And this is an example which we have seen in our default code when we wrote our Hello TDL program. We have types of definitions. We have categorized them as interface definitions, data definitions, formatting definitions, integration definitions, action definitions, and system definitions. Interface definitions are definitions which are used in creating a user experience. So something that a user can see on his screen, and to give a better graphical output to the user are termed under user interface definition. The definitions in this category are menu, report, form, path, line, field, button, and table. Data definitions are used for storing the data, and the definitions in this category are objects, variable, and collection. Formatting definitions which are used in formatting the user interface are referred as formatting definitions. The definition in this category is border, style, and color. Integration definitions which makes the import of data available in various formats are referred to as integration definition. We have import object and import file under this category. Action definition. The action definition allows the user to define an action when a key combination is pressed. It also associates an object on which the action is to be performed. The key definition or the button definition falls in this category. System definitions are viewed as being created by the administrator profile. Any items defined under system definitions are available globally across the application. System definitions can be defined any number of times in TDL. The items defined are appended to the existing list. Hence, it is not necessary that you always append to one system definition list. As and when required, you can recall this list multiple times, and you can just create a new system definition and add your system values. But the existing system definitions cannot be modified. Under system definitions, we have system variables, system formulas, system UDFs, right? So when we are going to use this, we will be doing them in detail. Now, these are the definitions. So these are the main broad output of the definitions. Each definition has properties, has its own set of properties, which is referred to as attributes. Again, there is a predefined set of attributes provided by the platform for each definition type. The attribute specifies the behavior of a definition. How would a report look? How many forms will a report contain? How many parts will a form contain? All this will be a part of the attribute. A definition can have multiple attributes associated with it. Each attribute has a name that's predefined, and an assigned value that can be provided by the programmer. A value can either directly be associated to a given attribute or through some symbols or prefixes, which we will be seeing very shortly. Apart from a direct value association of the attribute, there are ways to associate alternate values based on certain conditions prevailing to the runtime values. So syntax is very simple. Under the definition type and the definition name, we have attribute name. Again, control space bar to get the list of attributes under the definition type, colon separated by a colon by its variable value. This value can be a constant or a formula, and we have seen an example of this. Classification of attributes. The classification of an attribute is done on the basis of the number of values it accepts, and if they can be specified multiple times under a definition based on the number of sub-attributes and the number of values. Hence, there are 7 types of attribute categories specified. Single and single list. A single type attribute accepts only one value and can't be specified multiple times. The attributes such as width, style are of single type. A single list type attribute accepts one value and can be specified multiple times. These attributes also accepts a comma separated list. For example, field attribute at line definition. Then we have dual and dual list. Dual type attribute accepts two values and cannot be specified multiple times in the same definition. For example, a repeat attribute at part level can be specified only once and takes two parameters, that's the line name and the collection name. Do not worry and stress on the examples much, because as when we will use, you will understand what is a dual and a dual list and how we have categorized them. A dual list type attribute accepts two values and can be specified multiple times. For example, a set attribute at report level takes two parameters, the variable name and the variable value, and the set attribute can be used multiple times. Triple and triple list. Triple type accepts three values. Example, object attribute at part level, object, colon, ledger entries, colon first and colon another value, a condition, but can be specified only once. A triple list type attribute accepts three values and can be specified multiple times. Example, switch. It's a attribute modifier and can be used across all the definition types. Switch, colon, the label of the case, colon, the definition name, colon, the condition, and this can be specified multiple times. And there is a peculiar attribute type menu item. The attribute type menu item allows the user to add a menu item in the given menu definition. However, depending upon what you are specifying, it keeps changing the number of elements in the menu item, and we'll see as and when we write TDL how it keeps varying. So shall we write one more code with an explanation, a proper explanation, right? So we will create a report which displays two parts, each part containing 2 lines and each line containing 1 field. Okay, so we'll just go here. So we have the second test file. Now this again we will add to our menu gateway of Tally. So before we do that, isn't it necessary to write the comments? So 2 semicolon indicates comment. This is to demonstrate the utility of interface definitions modifying menu gateway of Tally using hash, open square bracket, hash menu colon gateway of Tally. Now since we already know this, we are not going to search for it. Enter. Adding a new menu item to gateway of Tally, and we'll say add. Now the previous code we wrote added the first TDL at the end of quit, that's it's after quit. Generally when you just simply say add, it does it appending, it does it at the end of the menu. So now we will learn to do a placement. We just talk about the menu item being a very peculiar kind of discrete behavior of having a TDL, discrete behavior. So in the TDL, the one which we saw, we just simply added the first TDL and by default it went to the end. So now we will place where we want to add. Where you want to add, so first we will go to gateway of Tally and we'll say I want to add it after multi-account printing. So in this add where after add key item after this, what you want to add, demo TDL. What is the shortcut? So we'll just see D is used, E we can use E. What you want to do, display. What you want to display, my demo report. Fine. Adding a new key item to gateway of Tally after multi account printing. Now we have declared here, so we will define open square bracket report name. Now what does the report contain? Form. And now we'll give a different name to this form. We will say demo Then we give the form definition, demo. Form contains part. Now as per our code, we need two parts. So we'll say demo P1 and demo P2, which means part 1 and part 2. Just know the naming conventions we are giving is the way we can remember them. Part demo P1. Each part should contain two lines. So line demo line ln1, and you see this comma separated demo ln2. So this is comma separated single list attributes. Now line definition demo ln1 contains field demo fld1 1, and the field will contain a such as this is first field in first line of part 1. So now we'll be able to identify what is getting placed where. Similarly, now we will have to define line 2. Open square bracket, line demo ln2 field demo fld12 such as. Please note the coding standard and the naming conventions that we are following. This is second field in first line of part 1. Okay, so we finished part 1. Now comes part 2. So now we have to define the part 2. Open square bracket, part colon demo P2 contains line. So demo ln12 does 11 21 and demo ln22. Now define these lines. Line demo ln1 contains field and now define this. Set as this is first field in first line of part 2. Now line definition, the second line definition, line demo ln22 demo fld22 and set as this is first field in second line of part 2. Fine, and all we need to do is F12, TDL, F4. Obviously TCP cannot be refreshed. We'll have to add the text file or just remove this TCP and execute it from here, right? So this is going to be a better way for a developer, that if he executes the file. Now it says there is an error. It says demo, see there's an error here while compilation. It says field demo fd22 referred from line cannot be found. So what we have written here and what we have written here varies. So there's an error. Now if I change the spelling, correct it, we'll clear it. Now check. So this is some basic kind of compilation errors that Tally developer will give you, which you will not be able to identify when you are writing it into a notepad. So do you see demo TDL is just now below multi-account printing? That's because we said add key item after multi-account printing. And how did I get this string? I went to the here, control, left click, selected this, just scroll down. You know the sequence, right? Accounts info, payroll info, inventory info, quick setup, transactions, and if you see the names are here such that it indicates what it is. So multi-account printing. Now say if you want it after display, so just copy this, go back to your code, change this, and F12 product and features, F4, enter, just refresh your TDL and you will see it's gone up, right? So it's simple. Placement is also very simple. Demo TDL, this is the first field in the first line of part 1, this is the first field in second line of part 1, this is the first field in the first line of part 2, this is the first field in the second line of part 2. So you see this, parts are vertical and lines also go vertical, so they are just right below one another, and since each of them is having just one field, it is right below each other. Simple as that, right? So I think everybody would be able to create a simple TDL report, right? So these are some commonly used definitions and their attributes which we have used here. Right now we haven't given a title to our report, so have a complete habit of providing a title to the report, and we say demo TDL is the title to our report. So these are some commonly used definitions we have seen, such as we'll see info, skip and set by condition also. form is having parts and bottom parts, parts of lines, repeats, lines having line, field, repeat. So as and when we come across the other sessions, we will be using these attributes, right? So attributes of field definition, we have already seen, such as talking about info. Info also displays the data, but the difference is it acts as a label. So when a report is in edit mode, the field is skipped, whereas when it is written as status, it provides an initial value to the field but allows the user to modify the value. So what in case a user has written info and status both in his field? In that case, info will get a precedence over your status. And then there is an attribute called skip. So in case in the edit mode, though you want to provide an initial value which might later get changed or refreshed, whatever it is, the skip attribute can be used to by not allowing the user to enter that particular field. Set by condition is similar to status. However, you can provide your status text with some conditions. For example, control end. Here we can provide an if condition. If A is equal to B, then this, else empty. This is what you can provide in your set as condition. Right? So you can provide a set as condition like this. So you can give a condition. If the value is equal to B, then give this condition, else you leave it blank. So there is an if-else condition that you can provide at your status to show the output. What we have done is similar to this. You can make a nested if-else conditions for the status to make the coding look much neat. There is an attribute added, set by condition, which separates the condition and the value. So set by condition if, then value, set by condition if and the value, condition and the value, condition and the value, and at the last you can provide a status which will work as your else condition, so that if any of the condition provided by a set by condition isn't evaluated, your status will get executed. Then we have modifiers. So modifiers are used to perform specific actions on definitions or attributes. They are classified as definition modifiers and attribute modifiers. In definition modifiers, we have hash, exclamation and asterisk. We also call this asterisk mark as reinitializer. Hash we have already seen. Attribute modifiers are use, add, we have already seen add, delete, replace, option, switch and local. Definition modifiers that are used to alter the definitions are hash, which removes the or makes a change permanent. Exclamation exercises an optional definition. So based on condition, if there is something that you want to execute, will be prefixed with an exclamation mark. And then we have the reinitializer, which deletes all the attributes of the existing definition. So it makes the entire definition blank and you can restart writing the entire definition. Attribute modifiers are classified into static or load time modifiers, which is use, add, delete and replace. For dynamic or real time modifiers, we have option, switch and local. Static or load time modifiers. So the order, as we had been talking about TDL being a non-procedural language, the order of evaluation of these attributes has been predefined by the program, and that would be use, the normal regular attributes of the definition, the attributes which are specific to the definition. Then would be the add, delete, replace. Then would be option, switch and then the leave and then the local. Add attribute modifier is used to add a definition to add an attribute to the definition. Delete attribute is used to remove or delete something from the definition. Replace modifier is used in a definition to remove, is used to replace the existing attribute value with another attribute value. Use, it allows us to reuse the existing definition, that it could be the default or program written by the programmer. Local attribute is used in the context of the definition to set the values of a particular attribute for that particular definition. Option and switch can be used to specify conditional attributes. So this is one example that we have provided, where we have made use of the attributes. As we told, the attribute modifier sequence you do not have to remember, it is remembered by the system. So in case at this definition you have provided set as, style and then use. The use gets executed first, then the set as will get executed and then the style will get executed. Similarly, for the report attribute, use does not exist, so won't execute anything. Then the normal attributes get executed, so the attributes which are pertaining to report will get executed. So form 1 and form 2 gets executed. Then we have written delete form. Then add, delete and replace. So in the sequence you have written, so now delete is written first. So it deletes form 1 and form 2 because we have written delete form and we have not specified which form. So form 1 and form 2 both gets deleted. Add form 3 adds the form 3. Right? So this is how the sequence is maintained by the system. So you can try this out, creating a new report using the report 2 and locally changing the field values. And how to use a local attribute modifier is like this. You can simply say use and you can provide the report name and locally change the field value. So what we will do is, right now for each the existing report that we have created separate lines and fields. We will add one more part to this. Part, and we will say use. Now obviously because it is a part, you can use only another part and we'll say demo P1, right? And we'll just refresh our code and see how it acts. additional 2 lines. Now what we will do is local. Now what does a part contain? Line. Okay, which line? So in part 1 we have line 1. So demo ln1. Okay, in this what do you want? In this we have a field. So localize field demo fld1. Change the set as to this is part 3. Now let us refresh our TDL and check. F12 TDL F4. If the definition names we have written is correct, it will change. So okay, so it isn't changed. So there is some spelling errors in demo P1. What is my line name? Okay, it is demo ln1. Okay, but the field name is 11 and not 1. So this is why it isn't changed. So when I make this 11, F12 TDL F4. Now check, right? Similarly, copy, paste, and we'll just change the field name to, well, and part 3, second field. F12 T F4, Control A, accept, and demo. Okay, so what's the mistake here? In line 1 does not have demo FL2, line 2 has that. So F12 TDL F4, Control A, and demo TDL, right? So the things, you see the changes. So what does this local do? You have to give the entire path to your definition to get the values. So local, line, line name, locally, call a field, change the field, set as, and this. Now say to this line you want to add one more field. So what we can do is locally to this line add a field, and the field name is demo FLD13. Now does this field definition exist? No. So what we will have to do is we will define this field. So field colon demo FLD13 set as. This is a new field. Now see this F12T F4. What is this? Right? But to this line we have added a new field, but you notice this, it is just changing for this part and not the previous part. So this is the functionality of the local, that it will only change the attribute behaviors for the definition for that particular definition. So use and local most of the time goes hand in hand as and when required. Local is used to change the current definition type behavior. Then we have option, and option helps us, is an attribute which can be used by various definitions across all the definitions actually. That's menu, form, parts, line, key, field, import file, import object definitions. So all the definitions can use this. The only thing is the syntax goes as option, the name of the optional definition, and the condition that you want to provide. So option, definition name, and condition. So if this condition is true, this definition will get executed. If condition 2 is true, this definition gets executed. Note, we are not mentioning any definition type here, because where you specify the option, that is the definition type. And notice we have prefixed it with an exclamation mark. All the options are specified and evaluated in the order to arrive at a final set of attributes. So how it goes is, condition, it checks all the conditions in the loop. Condition 1, true or false, true, still it goes for the second condition. True or false, false. Condition 3, condition 4. Each and every condition is evaluated. So this is an example of an optional case. So when in this example, the default set as is default value. Option 1, sample option 1 has a condition of an output of a has a condition. 2 has a condition, 3 and 1 has the same condition, and 4th has a separate condition. So in this case, if condition 1 is true, this means that 1 and 3 condition definition 1 and 3 both can be executed. So the condition at option 1 is value from sample switch 1 set as, so that will get executed, and at 3 also we have a set as. Now this field cannot have two set as, so what will happen is only the last one, value from sample switch 3, will get executed and 1 will not get executed. And in case of 2, the set as value from sample switch 2 will get executed. In case of 4th condition getting satisfied, the set as will remain as default value, but the color of the text would be orange. So that's how the optional case works. Now coming to the switch attribute modifier. The switch case attribute is similar to the option attribute, but reduces the complexity and improves the performance of the TDL program. The option attribute compulsorily evaluates all the conditions of all the options provided in the description of code and applies those which satisfies the evaluation conditions, and this makes the code very difficult for the performance, because if you have 25 options, it is going to evaluate all 25 conditions. The attribute switch can be used in scenarios where evaluation is carried out only till the condition is satisfied. So the moment the condition is satisfied, the rest of the conditions in the list will not get executed at all. So apart from this, the switch can also be grouped by using a label. So as in companies, we have various departments, right? People of same nature of work are department together. Similarly, in switch, definitions with the similar kind of conditions can be grouped together, and one of that satisfying condition will get executed. So now with this condition, so this is an example, a visual view of this. This is group or case 1. So it has some conditions. In option as you could see, although the condition was true, it was going for a check for the second condition. In this case, what will happen is, in the first group, if the first condition is true, it will just loop out of the condition. If first is not true, then only it will go for the second condition for evaluation. and this will continue till it gets the true value. If it does not get the true value, it returns the default value. However, the moment it gets the true value, rest of the conditions aren't evaluated and just looped out. Similarly will happen for the next group and the next group and the next group. So you can have multiple groups formed in a definition. So here we have given an example of a group. So in this case, in this switch case, if this condition sample switch 1 is true, the second year will not get evaluated at all. However, similar with the case 2, if first one is true, this will not get evaluated at all. That is how it works. Now it is grouped based on this label case 1 and case 2. This label can be anything. However, as we are developers, we have given some static names like case 1 and case 2. You can provide any alphanumeric names, but please ensure that you group them properly, because in case you give them different names to each label, to each switch, so you say case 1, case 2, case 3, case 4, then it is as good as writing option, right? So if you can see note here, for switch 1 and switch 2, we have same conditions of providing a set as, and for 3 and 4 we have given different colors. So the condition of the output of the same nature has been grouped together, and the output of the same nature has been grouped in part 2. So this is how the switch case works. Then we have some special symbols: dollar, double dollar, add, double add, hash, double hash, colon, double colon, sorry, semicolon, double semicolon, slash, asterisk, asterisk, slash, plus, exclamation, asterisk, and underscore. So we do have a separate entire topic on this. That's the next thing that we are going to do. So do not worry about this. Then we have some actions. TDL is an action driven language. Actions are activators of specific functions with a definite result. Actions are performed on two principal definitions, that is the report and the menu. An action is always associated with an originator, requester, and an object. All the actions originate from menu, key, and button. An action is evaluated in the context of the requester. So where the key is performed, where the action is performed, and the object. Again, we have a detailed chapter on actions in TDL. So you need not worry about this. So the syntax is very simple: action colon action name, and depending what the action is, the parameters will follow. Then there are functions. There are some predefined functions for which we have seen the list, and we have user-defined functions. Again, for user-defined functions, we already have a recorded session on TDL procedural. Please refer to that recorded session for more details on user-defined functions. Predefined functions are the functions that are provided by the platform, and the list is available in the Tally developer function browser. User-defined functions are the procedural part of the TDL, and user-defined functions allows the application programmers to develop their own functions for achieving the functionalities required by them. You can loop the conditions or the statements. You can allow the evaluation of statements based on conditions. So there are n number of things that can be done by user-defined functions, also known as TDL procedure. Then talking about the data types. The data types in TDL specify the type of data stored in the field and the storage. TDL, being the business language, supports business data types like amount, quantity, rate, apart from the other basic types. So there are two categories of the data type that we have in TDL. There is a simple data type and compound data type. Simple data type holds only one type of data. These data types cannot be further divided into subtypes. For example, string, number, date, and logical. These are four basic data types of every programming language. Compound data type is the combination of more than one data type. These data types that form a compound data type can have sub data types. The data types that we have are amount, quantity, rate of exchange, rate of forex, aggregate, etc. So this is some simple table that we have of data types. For data types, we have number, string. This is a simple list. So string, date. In date, the subtypes that we can have is of the short date, it's the long date, universal date. Well, but it will return you a date. That's it. And we have logical. In compound, we have amount, which can return base or direct base, or could be forex, could be rate of exchange, could be a debit credit amount. In quantity, you can return number, primary units, secondary units. In rate, you can return price or the unit of symbol. We have rate of exchange. Then we have a data type called time, which can be a 12-hour, 24-hour with seconds, without seconds, prefix, AM, PM. Then we have date and time, which can return time or only date. Then we have duration, which can be returned in seconds, hours, days, weeks, months, years, year, month, date, hour, minute, days. So we do have that. And then we have the due date, which can be returned in days, weeks, months, and years. Please refer to the data types reference manual for details on each of these data types. Then we have the operators. Again, operators are special symbols or keywords that perform specific operations on one, two, or three operands and then return a result. So there are three categories. We have arithmetic, logical, and comparison. Arithmetic operators are supported in TDL is the plus sign, minus sign, division sign, and the multiplication. So that's plus, minus, asterisk, and slash. Logical operators we have is or, and, not, true, on, off, false, no. So these are all logical operators. And comparison operators is for comparing operands and returning a resultant value as true or false. So TDL supports the comparison operators like equals, text or the equal to sign, greater than sign, less than sign, in, null, between. So all comparison operators of your grammars and your mathematics can be used. There are also string operators like contains, containing, begin, beginning with, ending, like. So all these are some operators. Very important about the naming conventions for the definition names that we have in Tally is 1. All these are case insensitive. So whether you write a capital T or whether you write a small t does not matter to Tally. So it is identified as same. Space insensitive, whether you write T-A-L-L-Y or you write T space A space L-L-Y is absolutely same for Tally. While writing the definition names, Special characters are not allowed. You cannot write T @LLY. We do not allow that. Duplication name of the same type is not allowed. That means I can have a form by name demo. I can also have a part by name demo. So two different definition types may have the same name. Cannot begin with number. We can write demo 1, but we cannot write 1 demo. The number 1, numerical 1 cannot be written in the beginning of the definition name. Keywords cannot be used. There are certain keywords like the display, the action that we spoke about, or blank. So these are certain keywords that we have entirely which you cannot use. Now moving forward to special symbols. In the previous lesson, we have discussed about the various TDL components, right? Like the definitions, attributes, functions, symbols and prefixes, variables, etc. Right? In TDL, there are symbols which are used for specific purposes. And that's the reason why it's a part of the TDL naming conventions that do not use special symbols. Some special symbols are used as access specifiers and mainly are used for accessing the value of a method or a variable, field, formula, and some are for the general purposes like for giving a comment or for adding or subtracting. So we have two categories: access specifiers and general symbols. Access specifiers, usage of single @ it is a local formula. It's a specifier that refers that there is a local formula which has been specified at the interface definition, and the scope of the local formula is only within the current definition. A local formula is usually defined if the formula is specific to that particular definition and it is not used by any and not required by any other definition. Accessing local formula using @ symbol. So access specifier symbol is used to refer a formula defined within the same interface definition. The scope of the local formula is only within the current definition. A local formula is usually defined if the formula specified is not to be used, it is not for the utility of the other definitions. The value of a local formula can be accessed by using the symbol prefix symbol @. So as you can see in this example, set as :@HW local formula :HW hello world. So this output would be hello world. Then you can do this, try it out. You can just write a simple code and you can write a local formula and just try to show the output of the local formula. Then we have the global formula, that is using the double @. A global formula is the one which is defined at the system level and is available across all the definitions. So it can be accessed by any definition, and hence it has to be defined under a system definition. The value of the global formula can be accessed by using a symbol prefix @. Hence, when you need to write a global formula, it has to be written under the definition type system : formula CMP mail name, and this becomes your formula. So wherever you call this formula, it will come as its output. Then again you can just write your code on this. It's a sample that you can write out. Naming conventions, please be very careful on the naming conventions of your formula. It is case insensitive. It is space insensitive when you define it, but when you are accessing the value, it is space sensitive. So as in this example, while I am defining this, I can provide CMP space mail space name. Definition can have spaces, but while I am accessing, spaces aren't allowed. It will give you a red line under that particular formula name. Should not contain any special characters. By now you would have understood why we do not allow special characters. Each special character has a specific meaning. Cannot contain a keyword or an attribute name, and cannot begin with the number. So these are the naming conventions, and these naming conventions are standard across the entire TDL. Now the special symbol hash. The symbol hash can be referred for referring a field value or for modifying the existing definition. So for modifying the existing definition, we have already written we have written 2 codes, so you know that. And for referring to a field value, you can simply write hash the field name, and this text of this field will be referred here. So even this field will showcase hello world, and even this field will show you hello world. So again, for this you can write a TDL code, create a report, and by just try and write an hash HW and see how does your output look like. So the moment you change the hello world in field 1, automatically the value in field 2 will change. Definition modifier hash we have already seen. We have modified the gateway of tiling menu. Similarly, you can modify any definition type that you want. Now accessing value of a variable using double hash. For variable, again we have a very detailed chapter. So variable is nothing but a container of a data, which this data can be placed anywhere and can be called anywhere. So to identify this as a hash, identify that it is a value stored in a variable, it is double hash. So you can just try it out. Then we have accessing method using a single dollar. Any information from an object can be extracted by using a method or a UDF. The dollar is prefixed using prefix. The dollar the dollar prefix is used to invoke or deploy the value from a method or a UDF of any object, where the term method and object are TDL specific. Again, we have an in-depth coverage of this in our chapter objects and collections, which will be a part of our session 3. So please do refer to session 3. Then we have a double dollar symbol. In TDL, functions are inbuilt, and TDL programmers can also make functions. A function can accept 0 or more arguments and to perform a specific task on arguments and return a value. So while identifying that it is a function, a double dollar is used to make the system understand that what you are writing is a function and can return or may not return value based on the function's nature. Then we have certain general symbols for adding comments, which we have already seen, a single semicolon or a double semicolon. These and slash asterisk asterisk slash to comment multiple lines. So we have already seen this. Then we have the plus symbol, that is the line continuation character. It is used to split a lengthy line into number of shorter lines. By doing this, the programmer can see the entire line without scrolling left or right, and this also helps in debugging the code faster. Then we have a special symbol underscore. The symbol underscore is used to expose methods to ODBC. So what you can see as an ODB, whatever methods you want to see as an ODBC, it can be prefixed with an underscore. By prefixing the underscore to a collection name, it returns into a procedure which can be referred externally by passing the parameter as a variable. So an external application can also read the collection if it is prefixed by an underscore. Then we have the asterisk symbol, also known as a reinitializer. When an asterisk is used for an existing definition, all the attributes of the definition are overwritten. This is very useful when there is a need of completely replacing the entire existing description content with a new code. Then we have the exclamation mark. It is used to define optional definitions, where the optional definitions can be called with the help of the attribute modifier switch and option. And this is the end of our session 1. Thank you. And for further queries, do write to our support desk at support.tallydeveloper@tallysolutions.com.